just squaring up the block to make the packing piece to go behind the tool holder. It'll fill the gap on the stop the clapper box. That's the fourth side. I'm not doing the ends, it doesn't need it. 20 thou depth of cut. We're running about top speed. It's a short stroke. Sounds a bit better. Try a slightly faster speed, so we're now on a feed of 0.24, so what's that, 10, 12, 14 thou per rev. Creating quite a bit of a vibration, you can hear it hammering. Better once more teeth are in contact with the cup. That fits alright. Just cutting the tapered face. So that's where we've got to. That's the finished piece to stop that. You stick it on. Oh, you can tell at the back that edge is a tapered fit. So you slide it down till it locks. And nick up the Allen key. So it can't vibrate off. And that's locked it. It does have the advantage of, if I decide I want a little bit of lift, I can control it by moving the taper out of that gap. And if I want a little bit more, I can always make a new washer. Bit thinner. So final bit's going to be grind up a few cutting bits, different profiles, and then see how we get on. My cutting bit's a bit too long, so I need to grind 1/4 inch off the rear end of it, and then I'll have a bit of clearance. What's happening is the back end of the tool here is rubbing on that, so I'm going to grind some more off the tool bit and start again. Getting quite a bit of springing on the toolbar setup. So I'll move it across, take a cut, and then take about 4 spring passes. You can actually see the thing deflect, which is no surprise because it's the best part of 10 inches away from the post it's locked to. I mean, I haven't actually adjusted it and it's still cutting. I think with the benefit of hindsight, the cutting bar could have been probably 1 3/4 inches, nearly 2 inches shorter. Couldn't have gone any bigger in diameter. And it will be interesting to repeat the exercise at a later date with a tool post mounted direct into the lantern post position. There's less elements and less movement, I would think. Well, it's slow. I'm not fussed about this not being perfectly in line because it is only a clearance zone, but I want that surface flat. So what I'm going to do is make up another tool, take this corner out and then just do a pass across with a round nose. Bring you back when we're nearly done. It ain't pretty, but I've got to do a finishing cut. So, zoom the wrong way. What have I learnt? Well, first thing, clearance is a problem. I think if I was making it again, I would probably just go for one mounted straight in there, or even take the clapper off and mount it straight on there. That would enable me to stick the piece further over. Not that that's a problem with this, but maybe on other stuff. Given how far that sticks out, that becomes a clearance issue again. The bar I've put on could do with being an inch and a half shorter, but it works as it is. There is play. I mean, even though the clapper box is a nice snug fit, there's still enough rock movement. You can see the bar deflecting as it takes a side cut. It's deflecting and then coming back. Obviously the bigger the cut, more deflection. It's all, you can work with it all. I guess the main element of the time taken is continually having to undo the boring bar and rotate it to bring the cutting tip round, and that's a function of the diameter of the bar, the diameter of the hole, and the clearances involved. A thinner bar with or a longer tool bit would reduce that, but you'd end up with more deflection, I think. I have heard and had a few comments where guys actually run the thing cutting in reverse, so deflection of the bar is less of an issue. My only concern with that is, on this particular shaper, and on quite a few others I've seen, the tool head, that bit, is mounted to that bit on quite a small spindle. It's probably only about that size, cast iron, and cast iron isn't very good in tensile strength, and all of the forces are trying to pull that head off the ram. So it wouldn't take much to give that a crunch, and then you're having to make a new one of these. So yeah, I think if you got the right shaper, or you're very good and don't try and take too big a bite, you could probably get away with it. I'm a nervous machinist, so I shan't be. Yeah, the other thing is making sure you've got your cutting bits, working out what best geometry is for them. It's took me probably the most amount of time trying to work out how to get in to that shape. Righty, I'll swap the tool bit over, I'll go up that far edge, and then I'll do a finishing cut along there, and that'll be me done. I shall bring you back when we're done. Right, well, thought I'd investigate where the flex and that was. Now I can move that 15th thou, something like that. I can hear the movement in the gib. You can't, but I can hear the movement in the gib. There's movement in this joint here. There's nothing there, and there's movement between this and the clapper box. Not a lot, but it's there. Everything else is tight, and it's the combination of those two which, because of the distance and the leverage it's got, what I could see was it was starting to cut and then deflecting away out of the cut and then back. So each cut was perhaps taking, and bearing in mind I'm only cutting probably 5-6 thou depth of cut, the 6 thou feed, it was enough for it to flex, and then it was taking 4 or 5 strokes to take that material out. So very, very slow going. It ain't the prettiest, and I've not tried hard to blend it in. It really wanted a little bit more off this face, a little bit more off this face, and then smoothing up on the bottom. But for what it's doing, which is to house that, it's going to be fine, I hope. So yeah, it's been educational. Well, this is a kind of finishing up short clip. I'm not sure where I'm going to be tagging it on, so bear with us. So if we ignore the discs for the moment, I've got a tailstop which goes with my rotary table, and then I needed an index unit for direct indexing and driving my gears that I'm going to be cutting. So what I'd elected to do was, instead of doing a single gear at a time, which is how the original design, which I've blatantly copied from, showed by JB from Oz, and I'll put a link below, nip over to his channel, give him a subscription, and click as many thumbs up on his videos as you can. He makes some change gears for his lathe, which is basically what I'm doing. So what we got is, I'm going to be cutting 2 or 3 or 4 or 5 of these gear blanks. I've got to bore them out, fit them to a mandrel, and then the mandrel will sit in between the point on here and the point on the end of this index unit. So for all intents and purposes, I'm turning between centres. No, only in this case I'm gear cutting between centres. So I've got to make a shaft that goes through here, carries the centre, carries the drive dog, and then the shaft that carries the gears has got to be a locking shaft, so it'll have a thread on one end, and then a location for me to set the drive dog into and lock it so it can't move. On the other end, I'm just going to shuffle that along a bit. On the other end, I've got an index disc, so that will be, for all intents and purposes, a load of concentric hole patterns. One hole for each tooth, I think it is, or tooth gap, I need to check. But I'm making a 135 gear, 135 teeth, 127 teeth, and then, as I say, half a dozen or so others at around about the 60, and they're all going to be made out of steel. These are laser cut plate, and they're all for thread cutting on my Boxford lathe, and the idea is to make up some spares which I can then sell on. So you've got an index gear and then an index arrangement which locks the PCD disc, which is a disc with a groove on it. The diameter of that groove is exactly the PCD, the disc of the gears that you're cutting. That is fixed to the shaft, which travels through this head and links up with the gears. So as this PCD disc is rotated, so do all the gears. The index wheel is only pinned to the PCD wheel via the index pin. So as you pull the plunger, index it, drop it in the next hole, what you're actually doing is moving this shaft around to bring the next tooth into position. If you take a look at Marcus's video on it, he's got, I think there's 3 or 4 in there. Take a look at the editor's cut. It's a bit more detailed, shows you a bit more what the setup is. Now Marcus made all his PCD discs and the index discs on I think it was a pantograph he used, and they're all made out of plastic and they're very slick, very efficient. I've elected to make mine out of steel because I've got no means of cutting plastic, and I might end up making quite a few. So the jobs are many. I'm starting on the main head. I bought that for another job which has only been used once, so the issue was making sure that this, I can match the centre height with it, and I can. And I think the largest disc I'm doing is 7.5 inches roughly, so I've got 8-inch discs to turn them down. So it's going to be quite a big project for me, lots of components going in, and I hope to bring it to you for your viewing pleasure. I hope you enjoyed what we're up to. Last thing on this main thing, having squared the bottom out, drilled and tapped, lock it all in place. So that then, well, all that assembly has to fit on my shaper table. So this end sits on the free end, and all of this lot sits at the tool head end. I've got 14 inches, sorry, 14 3/4 inches just inside. So hopefully when I put the next video up, we'll be making the shaft for this, making the dog arrangement, and then I can concentrate on getting the discs turned and bored and holes drilled and all that paraphernalia. Cheers for watching.